Thanks for joining. This is a RISE Masterclass on assessing and designing dwellings for EWI, presented by myself, David Stubbs, and John Milner. So just a bit of housekeeping before we get going. Today, we'll be talking a bit about Bailey Garner, who we are, and then we'll delve straight into what external wall insulation is, why you would install it, and how to survey for external wall insulation. We'll then move on to designing EWI, what materials you might want to use, some practical implications and industry standards, and then finish off just identifying some risks and how to mitigate those risks, and then wrapping everything up at the end. So a little bit about us. I am David Stubbs. I'm a sustainability engineer at Bailey Garner. I have just over 3 years experience in retrofit and I'm a qualified coordinator, assessor and domestic energy assessor.
And hi everyone, my name is John Milner. I'm a specialist consultant with Bailey Garner. I've got more years than I care to mention experience in retrofit, and I've also undertaken project management on EWI projects.
Cheers, John. So a bit about Bailey Garner. We are a medium-sized business. We have roughly 250 to 300 employees based across 3 offices across the UK. So that's in Manchester, Birmingham and London. We've been doing retrofit projects since around 2008. So that's preceding SHDF and the PAS standards. We have quite a lot of experience in this area. We take an environmental approach to everything that we do, really. So we were established in 1976. We are an accredited B Corp, and we have our own in-house sustainability team. We are also a multidisciplinary practice, which means that we have a wealth of knowledge across lots of different areas, from architecture to building surveying, excluding structural engineering. So straight into it, what is external wall insulation? External wall insulation is often abbreviated to EWI, and that's how I'll refer to it for most of this, to be honest. It involves applying a layer of insulation to the outside wall of a building and finishing that insulation with a protective layer of render or brick slip. External wall insulation is often used for solid wall properties because they can't receive cavity insulation, although sometimes cavity wall properties can receive external wall insulation if they're going for a really high performance. Windows are often replaced at the same time as installing external wall insulation. This is to allow for correct interfacing of the measures, although it's worth noting that the exact age of the windows, or rough age at least of the windows, should be determined prior to replacing them to make sure that you're not throwing away perfectly good windows. So why would you install EWI? There's a number of reasons and benefits for installing EWI. First and foremost, the existing wall construction may be a big reason. So if a property is solid wall construction, as I mentioned, you won't be able to install cavity wall insulation on that property. And so some form of solid wall insulation will be required. That can either be IWI or EWI. The benefits of EWI over IWI are that it's lower disruption. If you think about installing insulation inside somebody's home, you may have to decant residents from certain areas of the property and then have people walking all in their property, which you don't get with external wall insulation. Another benefit is that EWI retains the thermal mass of the building inside the thermal envelope. So what this means is that the masonry and brickwork remain on the warm side of the insulation. This reduces the chance of interstitial condensation. Interstitial condensation is where the dew point forms inside that buildup, and over time can lead to the deterioration of the structure. And so it's to be avoided at all costs. EWI also leads to the consistency of the thermal envelope. So it creates a consistent envelope around the building, which can reduce thermal bridges. A thermal bridge is where there is an area of reduced insulation or a different material, which can provide an easier route for heat to leave the property and can lead to cold spots internally, causing damp and mold, and just reducing energy performance. Another benefit of EWI is that there's no loss of internal floor area. So as with IWI, you would have to remove 100 millimeters from the inside of the wall. You don't have to do that with external insulation. And then finally, EWI can form part of a structural stabilization method. So this is typically seen with system-built properties where there may be some recurring defects. You can use external insulation along with a structural membrane to essentially reinforce that wall and benefit the energy performance at the same time. Next, we're going to look at surveying a property for EWI. So we're going to touch on things to look out for during a desk-based study, as well as when you're actually on site, and then run through a quick worked example of a project that we have worked on recently. So when doing a desk-based study, there are some key things to look out for. So first and foremost, any planning constraints. So this can include any conservation areas, local listings, or anything like that. These designations can have quite a large impact on whether external wall insulation will be allowed by the planners. And so finding out if a property that you're looking at is within one of those areas or is listed is really important to do soon. The next thing to look at would be hard to treat areas or properties. So when I say hard to treat, mainly meaning sort of tile hung properties or cross wall properties. So these properties vary in construction, and so it can be quite difficult without opening them up to know how they're constructed and therefore how the external wall insulation will interface with the building. And so you can narrow down these properties and identify them as early as possible, so that if you do need to remove some tiles to investigate the construction, you can organise that to happen. It's also worth noting that warranties are more difficult to achieve on tile hung and cross wall properties. Another thing to look for is access constraints and parking provisions. So looking at this image on the right hand side, this property here is a property that we worked on recently installing external wall insulation. And it's obviously quite a restricted area. It's a very residential street. And so figuring out how to get materials to that site and around that site is something to be worked out and identified quite soon. And then finally, areas for material storage. So when you're doing a project like this, it's oftentimes not just external wall insulation that you're installing, but there might be some windows as well. Where are you going to store all of this material? How are you going to transfer it to site if it's being stored off site? These are all things to identify early and consider. Next, when you're on site, there are a number of measurements that you want to collect. So this isn't an exhaustive list, but these are just some key ones that are sometimes overlooked, but that are very useful when a retrofit designer is designing external wall insulation. So first, it would be the DPC level. This is the height of the damp-proof course above the finished external floor. So you can see that photo on the right-hand side, somebody measuring a DPC level. Very useful. We'd like to see those photos. The next thing would be externally fixed utilities. So this would be meter boxes, cabling, stuff like that, things which might need to be moved in order to allow the insulation to be installed, potentially being replaced or insulated afterwards. But you need to identify those to be able to move them. Bay windows, these can be quite a complicated area. We'll touch more on this in the next slide, which is the example. And similarly with porches, we'll touch more on these on the next slide. On site, you can far more easily identify the actual construction of the building. So doing a quick look around on Google Maps, sometimes a wall might have stretcher bond brickwork. And so you think that it's a cavity wall. However, you get to site and you measure it and it's thinner than a cavity wall should be. It's those sorts of things, being on site, being able to measure and actually investigate construction. That's what you should be doing on site. The next thing is identifying service penetrations, vents and flues. So if there's boilers, where are the flues? All of these things should be identified and plans put in place to make the installation phase easier. One of the key things to collect while on site is a list of defects and remedials. So this can be slightly overlooked. However, it's arguably one of the more important aspects to collect. So an example of a defect would be faulty rainwater goods. So perhaps a leaky gutter that was soaking a wall. If you didn't identify that in the assessment and just went and installed the external wall insulation, you may compromise that insulation with moisture. You may trap moisture inside the wall, which could lead to damp and mold internally. And so being able to sort these issues out prior to installation is really, really important to making sure that the life of the EWI is extended as much as possible. And then finally, as we touched on in the last slide, site-specific restrictions. So you can identify side alleyways and areas of reduced access by a desk-based study. By actually measuring those areas, you can only do on a site survey, and it's really important to get those measurements to know if the insulation will block access to a certain area and how you might get around that. So this is an example of a property that we worked on recently, installing external wall insulation. This property isn't in a conservation area, doesn't really have much planning value, but there's still quite a few things to consider when looking at this property. So firstly, the soffit depth. So the soffit depth is the distance from the externally finished face of the wall. So with EWI or without, whatever that external finish is, the distance from that to the fascia board, the depth of the soffit. There is a minimum depth that is required here. And so getting a measurement of this depth, you can then know whether installing EWI in this area will exceed that minimum depth requirement. If it does, you may have to extend the eaves or use a higher performing insulation to reduce the thickness of the insulation. The next thing is bay windows. So as I mentioned in the last slide, collecting measurements on bay windows is important. The main reason it's important is because they're all different, really. They're all different shapes, all different sizes. And so just by looking at one, you can't really know what size it is, what measurements you have there. You have to go to site, you have to get those measurements of the windows. It's also important to look out on site on bay windows, how old the windows actually are and whether they will be being replaced at the same time. If not, it can be quite difficult to detail EWI around existing windows in bay windows. You'd require sill extenders and things like that. So gaining an accurate age of the windows and accurate measurements of the bay windows is really, really critical. As I touched on before, services and penetration. So quite a small little bit to the left-hand side there. But this could be a meter box, this could be some cabling, knowing where these things are and how you're going to deal with them. Perhaps you might remove them, install the external wall insulation, and then reinstate them with an insulated meter box, for example. On the top right, we have unique features. So as I mentioned, this property is not in a conservation area. It doesn't really have much planning value, but it's still important to take note of these unique features. If this wasn't recorded and we didn't know it was there, perhaps the designer might make a design for the EWI, gets to site, and then the people on site get to this area of the wall, don't quite know what to do, so they make it up, perhaps causing a thermal bridge or something worse. And so it's really important to identify these features and be able to deal with them. Additionally, if this was a traditionally built property or a listed property or something like that, you might have to reinstate this feature if you were to do EWI. The next thing to look at is the garage. So this is fairly unique, like a side attached garage there. It's fairly unique. One of the main things to think about with the garage is how it affects the continuity of the insulation down that elevation. So if you imagine the garage attaching to the wall, there's going to be gaps in the insulation where that occurs. How are you going to deal with that? How are you going to reduce that thermal bridging risk? And then additionally, how the thickness of the insulation you're putting there, how much does that affect the access to that garage? Does somebody park their car in there and you putting 100 mm insulation on the wall then makes it so they can't? These are all things to consider. And then, as I touched on in the last slide, the entrance porch. So on this particular property, we did need to reduce the thickness of the insulation in this entrance porch. In order to do that, we needed really accurate measurements of how big the porch actually was. And also as well, there is a risk when reducing that thickness of insulation that you create a thermal bridge. And so having accurate measurements is essential to being able to do those calculations and ensure that thermal bridging risk is reduced. So next we'll move on to the designing portion of the EWI. So EWI is most often supplied as part of a system by a system supplier. What the system supplier does is effectively gathers all of the necessary materials for the insulation into one place. So that's insulation, render, beading, fixings, gathers them all together into a package that can then be installed. The benefit of using a system is that it will come with associated warranties and guarantees. So you can see on the right-hand side there what's called a British Board of Agreement certificate. And this basically just states that this system has been tested and meets certain criteria. They can be quite lengthy, but it's really important that they have this BBA certificate. The system supplier will often have technical support and design details available. So this is really important if you are doing complex details on a property, being able to have that direct contact with the system supplier to advise you how to correctly install that area of insulation to reduce that thermal bridging risk and ensure a quality installation. And then finally, it's worth noting that for grant-funded works and Trustmark approval, EWI systems must hold a current BBA certificate. So getting a system with a VBA certificate is essential if you're doing grant-funded works. So how would you choose a system? Firstly, moving top to down or top to bottom in terms of most to least important, not saying any are more important or less, but just in terms of a scale, the system component and performance should be a primary consideration. So if you need to meet any specific performance targets, maybe a U value target on your project, you would need to consider that when choosing your system. Included in that is fire resistance as well. So the actual thermal performance of the material and the fire resistance. The system availability is also a really important thing to consider. So how easy is it to get the elements of the system? If you have a really big project and you don't have a constant flow of materials, then that can cause delays, that can be costly. And so it's really important to choose a system that has enough availability to do the project that you want to do. The responsiveness is also quite important. So different suppliers, as with any entity, will have different customer service levels and levels of responsiveness. It's really important the system supplier is responsive, because if you have any queries or you need somebody to go out onto site to check what you've done, check that it's okay, or say yes or no, you don't want to be waiting for 2 or 3 weeks for them to get out there. You want them to be as quick as possible, so that you can carry on doing the work and remain on program. And then next up is the design details. So as I mentioned, each system supplier will have their own pack of design details. These will vary in terms of complexity and amount and quality. And so choosing a system that has a good design pack is a very good idea. And then finally, customer service. So customer service is quite important for the handover portion. We won't go into that today, but we are doing another masterclass on the 18th of September, which is EWI installation and post works, where we will touch more on the handover phase. It's also worth noting as well that the cost of the system shouldn't always be considered as the main deciding factor. If you have a system that is more expensive but comes with a better detail pack, you might save yourself in time in installation, and then that time saved can then offset the extra cost of the system. And so it's really important to consider all of these elements as a unit, essentially. So next, we're just going to go through a few different materials that you can use for external wall insulation. This isn't an exhaustive list. This is just a few sort of common and not so common materials that you might see or might think about using on your projects, and just a few sort of benefits and drawbacks of them. One of the things that we're going to touch on is thermal conductivity. So thermal conductivity is a material's ability to transfer energy. So if you have a material that is highly conductive, like metal, it will transfer energy more easily than a material that is not as conductive, like insulation. So the lower the number, the better. So the first one we're going to talk about is expanded polystyrene, often abbreviated to EPS. EPS has a medium conductivity, which means that it's better than some insulations, but there are definitely insulations that are a lot better. It is quite a cost-effective insulation type. However, it is not a breathable insulation. So what this means is that it does not transfer moisture. It does not allow moisture to pass through it. This can be an issue if you are trying to install this on a traditionally constructed building. So one which might be built with clay bricks and lime plaster. You wouldn't want to use this insulation because you would be preventing the building from regulating moisture in the way that it's designed to. EPS also has quite a low fire resistance as well. So that's definitely one thing to be considered. On the benefits side, the installation is less affected by weather conditions. So because this material is non-breathable, it's non-absorbent, it doesn't take on any moisture. And so if there is slight moisture around, it doesn't mean that the site teams have to stop their work. And then because of that, EPS is often easier to store and more workable than other types of insulation. The next quite common insulation that we're going to talk about is mineral wool. So it has quite a low conductivity, slightly lower than EPS. However, it is breathable. So for those properties where you want that breathable aspect, where you want to allow the property to regulate moisture in the way that it's designed, this would be quite a beneficial insulation material to use. It is on the more expensive side, but it also is very fire resistant, being class A1. Because it is breathable, it does take on moisture. I don't think it's technically absorbent, but it will take moisture on. It does require protected storage. and it has a slightly lower workability than EPS. The next one we're going to talk about is phenolic foam. So this is not as common, but it could have its use cases. So it has a very, very low conductivity compared to the other materials that we're looking at. What this means is that you don't need as thick a layer of insulation. So going back to when we were looking at our on-site example earlier in the garage, if we were reducing that space in the garage too much by insulating, we could gain an extra 50 mil, for example, by installing phenolic foam instead of mineral wool in the garage, which would potentially allow for access to be maintained. And then another thing to consider is that phenolic foam is quite expensive and it's quite brittle, so it does snap. And some medium fire resistance, however, if burnt, it will release toxic fumes. So it's definitely one thing to consider. And the last one we'll touch on is wood fiber. So wood fiber has the highest conductivity of any of the materials today, so transfers the most heat. It is breathable like mineral wool. However, it does have a low insulation performance and it's quite expensive. Because it's wood, it also has quite a low fire resistance too. And like mineral wool, requires protected storage. It's worth noting that there are no EWI systems made of wood fiber that have a warranty. And so no wood fiber EWI systems that can be used on grant-funded works at this time. However, some IWI systems do exist that have warranties that mean they can be used on these grant-funded works. So next, we're just going to look at a couple of sort of practical implications. So this is mainly around the construction phase plan. So sort of touching a bit more on what we touched on earlier. So one thing to consider, and this isn't necessarily specific to an EWI project, it's quite transferable, but it is quite important for an EWI project, especially if you're trying to keep insulation dry. Where are you going to store that insulation? Are you storing it like this pile of plywood is stored where it just gets wet and ruined? Or do you have a safe warehouse? Is it stored on site or off site? These are all things to consider. Another thing to look at is deliveries and traffic management plans. So if you are doing a big project and you have a lot of material coming to site, how are you going to manage that traffic in the local area? You don't want to annoy the residents. You want to keep everyone on side. It's really, really important to consider that. Another thing is access requirements. So with external wall insulation, this can be a slight issue if you are, say, insulating a terraced house and you're insulating the rear of that terraced house. How do you get the insulation to that rear elevation? Do you have to take everything through the resident's house to get there? Do you have to put down some protective stuff on the floor? These are all things to consider. And then finally, waste management. So this is sort of goes for any project really. How are you going to be getting rid of that waste? Where are you going to be storing the skips? If you've got skips, are you going to be suspending parking bays? These are all things to consider. The next is just a couple of industry standards. So some of you may or may not have heard of the Insulated Render and Cladding Association, otherwise known as INCA. INCA is a trade body representing the EWI industry. They provide access to technical guidance and resources, which are very, very useful when installing EWI. So within their guidance is basically a suite of technical details for brick slip and render finished EWI. These details are tested and proven to reduce weathering and thermal bridging. So if an EWI junction is installed to the specifications set out in the INCA guidance, it's considered to be PAS compliant with a low risk of thermal bridging. So you can see on the image on the right-hand side there is an excerpt from the INCA guidance, and it's essentially showing how to detail a ground floor to wall junction in order to reduce the thermal bridging and remain compliant. If junctions aren't installed to the standards set out in the INCA guidance, then thermal bridge calculations will be required to show that that junction meets a minimum surface temperature factor of 0.75. The surface temperature factor is a measure of the temperature on the inside surface of a junction, which can indicate whether damp or mold will form in that area, and is outlined within BRE IP 106. And finally, at the bottom, there are also a suite of British standards which set out requirements for specific insulation materials. So two examples at the bottom there is BSEN 13499 for EPS insulation and 13500 for mineral wool insulation. These are the primary resources to follow when installing EWI, the INCA guidance being used specifically for junctions. And then for the actual requirements of the material being installed, you would use the British standards. So what are the risks which can occur when installing EWI? So here's just a few risks listed out. Again, this is not exhaustive. Anything can really happen when you're doing any of these projects, but these are just some sort of key ones and recurring ones that can be easily avoided. So firstly is inappropriate system selection. So this could lead to performance targets being missed. And the best way to mitigate this is by conducting an extensive survey, which encompasses all of the measurements and ensuring technical due diligence is followed throughout the process. The next one is a non-compliant design. So a non-compliant design is a big risk because it can cause delays. It can cause things to be installed which shouldn't have been installed, potentially needing rectification. The best way to deal with this risk is just to comply with the PAS standards. So there is PAS 2035-2023, which should be followed for any of these projects, and PAS 2030 and M4 for EWI, which essentially sets out all of the regulations around installing external wall insulation. So the next one down is poor EWI interfaces. So as I mentioned earlier, it's not very often that EWI will be being installed on its own. A lot of the times it might be being installed with windows as well. And so having the correct detailing between these different measures is important. It can reduce the chance of thermal bridging. It can reduce penetrations being made in the building fabric and reducing air tightness. So the best way to mitigate this is to have effective communication with the lead retrofit designer and on-site team, and just being able to get across exactly what was designed. The next one down is an inadequately developed design. So one of the risks of an inadequately developed design is that it's missing key information. This could lead to people just making it up when they're on site, and then thus doing something non-compliant, doing something that causes further issues down the line or reduces thermal performance. The best way to mitigate this is just to ensure that the design is as robust as possible, ensure that there's as much information so that people don't need to make those guesses while on site. And then the final risk is changes to the building envelope affecting ventilation. So when you install EWI, most of the time, the air tightness will get better. The air permeability of the dwelling will decrease. Yes, decrease. The air permeability of the dwelling will decrease, which will mean that the air tightness is better, which, if the ventilation within the property isn't up to standard, can lead to reductions in indoor air quality and potentially dampen mold. The best way to deal with this is to ensure that each property has its own ventilation strategy, incorporating a specific building air tightness, and is in compliance with approved document Part F. So to conclude, what are the key takeaways from today's session? So firstly, EWI can be an effective measure in reducing a building's energy demand, and it can also provide a very durable, low maintenance finish for the building. It's really important to have adequate information from an early stage to allow for an effective and robust design. The comprehensive design phase is critical to reduce the chances of people making this work and doing things wrong on site. The correct system evaluation is helpful. So choosing the right system for your project, not necessarily just doing it on price, but weighing up all of the options is really useful and can be very beneficial. And then finally, the risks at the installation stage are vastly reduced if the assessment and design stages are carried out effectively, because it just allows for the whole process to go a lot smoother, less return visits to site, less things going wrong. So that brings us to the end of our presentation.